Okay then, Year 8. So we're carrying on our work on waves and we're having a look at the electromagnetic spectrum today. So, what I'd like you to do is just to recap our current knowledge on waves, is pause the video here and see if you can complete these words for me. Great, so hopefully you've been able to get all 8. And number 1 is waves, number 2 is longitudinal, number 3 is transverse, 4 is speed, 5 is frequency, 6 is hertz, 7 is wavelength, and 8 is the electromagnetic spectrum. Hopefully you got them all right. If you didn't, don't worry too much, just make sure that you've corrected them. Now, the two main classifications of waves are transverse, which is where we have motion in a perpendicular direction to the direction of travel, so at 90 degrees, and longitudinal, which is where we get compressions and elongations. Easiest way to picture this one is if you imagine a slinky spring. When you move it backwards and forwards, the way it compresses. Both involve vibrations, both transport energy, and neither transport any form of matter. Now, what I'm going to do, I'm going to show you a video now, which I just want you to look at, funnily enough, and watch, and it will just really help to explain the 7 different types of waves in the electromagnetic spectrum. Okay, if for any reason there is an issue with the video, I've included the link down the bottom here for you. So here we go.
Shh! Remember my instructions. Visible under X-ray glasses.
What are you on about, Paula?
Remember my instructions. Visible under X-ray glasses.
What?
It's a mnemonic, Alex. A sentence used to help us remember the 7 different types of waves in the electromagnetic spectrum.
Okay, but what is the electromagnetic spectrum?
Right, well, we know that there's 2 different kinds of waves.
Transverse and longitudinal.
That's right. Well, now we're just going to look at them in more detail, starting with light.
Light? That's a transverse wave, isn't it?
Correct. And a very fast transverse wave. Light travels at 300 million metres every second.
Which is very fast.
And it's not the only one. There's a whole family of waves with very similar properties, and they're all called electromagnetic waves.
Electromagnetic waves. Got it.
Right. Now, the first thing we need to learn are the names of the 7 electromagnetic waves in order.
How do we do that?
Easy. Remember my instructions.
Visible under X-ray glasses.
Yes. Now let's look at the words. R is for radio waves. M is for microwaves. I stands for infrared. V stands for visible light. U stands for ultraviolet. X is for X-rays. And G stands for gamma rays.
Okay, that makes sense, but why are the waves arranged in that order?
The waves are arranged according to the size of their wavelength and frequency.
Oh, I know what this means. If we take a wave like this one, the distance from one peak to the next peak is the wavelength, and the number of peaks or complete waves you get in 1 second is the frequency?
Precisely. Now let's see what the waves look like for each of the 7 types.
So if we look at wavelength, radio waves have the longest wavelength and gamma rays have the shortest wavelength?
Right. And because the changes in the wavelength are so gradual, this is called the electromagnetic spectrum.
So I hope that all made sense. Now, electromagnetic waves have the same features as we just heard. Okay, they're all transverse. Okay, they travel at the speed of light, which is 300 million meters per second, and they can travel through a vacuum, i.e. space. Now, if you remember the visible light spectrum, we looked at it last week where we created a rainbow. Okay, now Newton carried out that amazing experiment that proved that white light was made up of all of these colours, which was contradictory to the belief at the time, because they thought that white light was pure and it was sent from the heavens. Okay, but he proved by shining light through a prism, then through a slit, or using a slit, I should say, to isolate each of the individual colours, and then shining that colour through another prism, that there weren't any impurities or imperfections imparted from the prisms into the light. So if he chose the green light, or the green ray of light, went through the slit, through the next prism, the only light that came out of the second prism was green. And that was awesome, because it proved that the white light was made up of all of these colours. Okay, now the electromagnetic spectrum is used in a range of ways in modern life. So if we consider radio waves, okay, now radio waves have the lowest frequency and the longest wavelength. Okay, so they are at one end of the spectrum. Okay, and they're generally used for TV signals and communication at that sort of base level. Now, as we move through, we get microwaves, infrared, visible light, ultraviolet, X-rays, and gamma radiation. Okay, and gamma radiation, it has the highest frequency, so the highest number of complete waves per second, which means that they have an incredibly short wavelength because there's so many of them in a second. Now, a literacy point here. Okay, infra means below. So infrared means below red on the spectrum. Okay, now how it was discovered is another interesting story, and rather than me boring you and you having to listen to me talk, I've got a nice video for you to watch again.
When you gaze at the sky, you marvel at its intensity. Who knows how many stars there are? This question has fascinated scientists, philosophers, and dreamers throughout the ages. One of them was Sir Frederick William Herschel, born in 1738 in Hanover, Germany. Herschel became well known as both an astronomer and as a musician. He moved to England in 1757. Herschel is famous for his discovery of the planet Uranus in 1781, the first new planet discovered in the modern era. But Herschel made another dramatic discovery in 1800. He wanted to know how much heat passed through the different colored filters he used to observe sunlight. He noted that filters of different colors seemed to pass different amounts of heat. Herschel thought that the colors themselves might be of varying temperatures, so he devised a clever experiment to investigate his hypothesis. He directed sunlight through a glass prism to create a spectrum, and then measured the temperature of each color. Herschel used 3 thermometers with blackened bulbs for each color of the spectrum. As he measured the individual temperatures of the violet, blue, green, yellow, orange, and red light, he noticed that all the colors had temperatures higher than the controls. Moreover, he found that the temperatures of the colors increased from the violet to the red part of the spectrum. After noticing this pattern, Herschel decided to measure the temperature just beyond the red portion of the spectrum in a region where no sunlight was visible. To his surprise, he found that this region had the highest temperature of all. Herschel's experiment was important because it marked the first time that someone demonstrated that there were types of light that we can't see with our eyes. What Herschel had discovered was a form of light beyond red light, now known as infrared radiation.
Okay, so carrying on. The electromagnetic spectrum is a continuous range of wavelengths. As we've seen, we go from a very long wavelength with a low frequency to a high frequency with an incredibly short wavelength. Okay, now the type of radiations that occur in different parts of this spectrum have different uses and dangers depending on that wavelength and frequency. Now, I would like you, please, to copy this table down, pause the video, and see if you can come up with a use for each of the wave types and a danger for each of the waves. Okay, so pause the video, copy it down, and we'll go through it. Okay, so hopefully you paused the video there, copied down the table, and have got at least one for each of these. So radio waves, they're used in communications, radio, TV, okay, and they're normally safe unless they're very, very concentrated. Microwaves, again, they're used in communication and heating food and water, and they can burn if they're concentrated. Infrared, security devices, remote controls for your TV, things like that. Again, they can burn if they are concentrated. Visible light, okay, so the spectrum of colour that we created last lesson, okay, used for seeing and photography, okay, and it can cause burning and blindness if it's concentrated. An example of this is when you use a magnifying glass in sunlight, you get a very concentrated beam that can start fires. Or if you look at the sun through any kind of magnification, it can cause severe damage to your eyes. Okay, ultraviolet light, okay, used in suntan lamps, and it can be used for killing bacteria. It can cause skin cancer and retinal damage again. X-rays, I'm sure we all know what an X-ray is, and hopefully not too many of you have been unfortunate enough to have one. Okay, they're used for imaging of bones and detecting breaks. Okay, and the dangers are they can cause cell mutation or destruction, which is why radiographers, because they are exposed to them all day, every day, actually, when they take an X-ray, they stand behind a lead shield and they wear the big, thick lead aprons to stop X-rays getting to their bodies. Okay, and finally, we've got gamma rays, which can be used for sterilization and also for killing cancer. And again, the dangers of gamma rays are cell destruction and mutation. Now, this is a fantastic diagram here. You can see that at certain frequencies, the electromagnetic spectrum can penetrate the Earth's atmosphere. You can also see that the wavelength gradually shortens as we go through the electromagnetic spectrum, which means that the frequency increases. Now, to give you an idea of wavelengths, the radio waves right down here at this end of the spectrum can be as big as a building. Now, these are, I can't explain the sheer size, but these are among the tallest buildings in the world. Okay, as we move down the scale, at this point, just at the end of radio going into microwaves, the wavelength is about human size. At the end of microwave going into infrared, it's the size of a butterfly or a needle point. Okay, we move into visible light, we start looking at protozoans. Okay, as we move into ultraviolet, the size of molecules, each individual wavelength is no bigger than a molecule. Okay, X-rays, each wavelength the size of an atom. And as we move into gamma rays, the size of a nucleus, an atomic nuclei, tiny, tiny, tiny wavelengths. Okay. Now, as you saw with the Herschel experiment, the temperature, okay, as we move through the scale, changes dramatically. It increases, it gets hotter. So, now I'm going to show you a lovely little song. Well, it's not that lovely actually, but hey, it's a bit of fun, and it might help you to remember the order of the wavelengths in the electromagnetic spectrum. If you can't remember my instructions, visible under X-ray glasses, maybe this song will get stuck in your head. So here we go.
The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. From the TV station to your living room, that is the work of radio waves. Heating food in just seconds, microwaves do that. Heat treatment for illness, take pictures in the dark. They are even in your remote control. Infrared radiation, the electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. Red, orange, yellow, green, blue, indigo, violet. That is the only part of the spectrum that can be seen by us. The suntan on your skin kill bacteria and viruses. Used to detect forgery, that is ultraviolet. The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. See your broken bones and your hidden bombs. That is the work of X-rays. Kill cancer cells and sterilize. Dangerous gamma rays do that. Now we have completed the electromagnetic spectrum. If you still do not understand, then play the song again. The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays.
Okay, so there you go, the electromagnetic spectrum song. Just a little bit of fun to end on. Now, hopefully that all makes sense to you. I have posted a quick question on Shobi for you to have a look at, and it's just about being able to identify the different types of waves in the electromagnetic spectrum. So I've named all 7 and I've put a definition in there for you as well, and I just need you to match them up. Okay? Speak soon, Year 8, and have fun.